Specific heat capacity, the three ways, guys. GCSE level, I'm sure you know how to do it. Insulated, electrical energy going into MC theta. I'm not going to go over this because that's GCSE. The second method is what we call the inversion method, right? So inside here we've got lead shots, and as you keep doing that, the potential energy gets converted into kinetic energy, but when it stops, eventually that turns into thermal energy. So you do that around 20 times. What would happen after 20 times? The temperature of the lead shot does increase. And if you can measure that temperature, if you can measure that change in temperature, knowing the mass actually does cancel out, knowing the height, which is 1 meter here, and the change in temperature, and you do that 20 times, you could work out this unknown specific heat capacity. And the one that I really want to do today is this. The only equipment that we've got and just recently managed to fix it. This is called a continuous flow method. Continuous flow. So this is called a continuous flow method. It's a better method because it reduces heat loss. So what do you have? All the variables. Q, A level, we call that heat. It's the energy going in. Because the energy is going in, thermal energy plus heat loss. It will take into consideration heat loss. So how am I going to measure energy? Arush, how am I going to measure energy? Use a joule meter. Where's the joule meter? There you go, boys. You know one of these plugs. So that's going to give me my energy. Hang on, what's mass? What's mass? Mass of what?
The water.
The water, absolutely. So what I'm going to do, I'm going to run water through. And I've got an immersion heater. So if I turn that on, that's heating up. And I'm using my thermometer, right? And if I read my value here, I have to allow thermal equilibrium again. I have to give it time for it to heat up. The water to get to a constant supply. So if you can see it, there's water coming out. The filament is heating up and the water is stagnant. It's like your kettle is going to heat up a lot. As I increase water, some water is taking the heat and then taking that out. What would happen? The temperature is not going to be as high as it should be. So for this flow rate, what I really should be measuring, for 1 minute, I should collect an amount of water. So that will be my mass 1. And I'm going to read my temperature here. That says that's 20, that's 40. That's 20, that's 40. What's my change in temperature? A difference of 20. I know my M1 because I'm going to measure it. I'm going to work out my specific heat capacity. My change in temperature is 20. How much heat I'm supplying comes from the plug, I know that. I don't know my specific heat capacity. But for that change in temperature, I know that's my heat loss. How could I get rid of heat loss? When would I have the same heat loss? My mass is going to change. What I'm going to do is I'm actually going to heat it up more. By heating up more, I want the same temperature difference. Let's say that's now 40. How much do I want this to be? 60. So I may vary my flow rate. When I vary my flow rate, the mass of water is different. My C is the same. I can adjust my energy so that my initial and my final temperature, the temperature change is the same. For the same temperature change, the same heat loss. So that stays the same. This heat loss are then equal. So what do you end up having? Two equations.